Scientists in Canada have defied gravity and physics by rolling a ball vertically down a wall. In a groundbreaking experiment at the University of Waterloo, researchers achieved what was once thought impossible, which is a ball moving straight downward against a vertical surface without falling. And I know some of you might be wondering, what is the use for this, or how does it defy gravity and physics? I'm going to explain in a minute. But first, hit that like and sub button to get more insight on new research happening worldwide. And link to the published study is in the description. The academic journal called Soft Matter, which published the study, titled it "Spontaneous Rolling of a Soft Sphere on a Vertical Soft Substrate," called the discovery groundbreaking, saying it challenges our basic understanding of physics. Researchers from Waterloo's team spent months in trial and error before capturing the phenomenon on high-speed cameras. The key was the ball's slight deformation as it rolled. The front edge acted like a closing zipper, while the back edge opened up, creating an asymmetry that provided just enough grip to sustain motion. This unexpected behavior could revolutionize soft robotics, enabling machines to inspect pipes, explore caves, or even assist in space missions where traditional mechanics fail. When it comes to how it defies gravity and physics, normally for an object to move down a vertical surface, it either needs to fall freely due to gravity or be pushed along by some external force. Rolling, which requires continuous rotation and frictional torque, is something typically seen on horizontal or inclined planes, not vertical ones. In this case, no external force was applied. The sphere moved on its own, and not by sliding or bouncing, but by rolling in a controlled, steady manner. This behavior contradicts conventional physics models, which predict that without a net external torque or a component of gravitational force acting along a sloped surface, such motion shouldn't occur. The discovery introduces a new kind of motion where deformation of soft materials and surface elasticity themselves produce internal forces, enough to generate spontaneous torque and movement. Dr. Sushanta Mitra, a professor involved in the study, described the moment of discovery. "When we first saw it happening, we were frankly in disbelief. We double-checked everything because it seemed to defy common sense. There was excitement in the lab when we confirmed it wasn't a fluke.